Welcome to HSEEG.
Equipment coming into electrical contact with power lines is the leading cause of crane-related fatalities. In urban environments, massive steel structures operate within feet of high-voltage infrastructure. The margin for error is measured in inches. The crane does not actually need to touch the wire to initiate a fatal event. High-voltage electricity can arc across open air gaps, seeking the path of least resistance to the ground. When that arc connects with a crane, the electricity energizes the earth, creating concentric rings of voltage rippling outward, a hazard known as step potential. If a worker touches the equipment, their body bridges the gap, drawing lethal current directly through themselves. Paradoxically, the safest place during a strike is often inside the crane. Operators are generally protected as long as they remain in the cab, unless a secondary emergency like a fire forces them to evacuate. Because an arc turns the surrounding air and ground into invisible conductors, survival relies on enforcing strict mathematical clearance distances, rather than simply avoiding a physical collision. The highest risk of breaching those clearance distances occurs before the lift even begins, during the assembly and disassembly of the crane. OSHA's subpart CC rule is absolute. No crane component may be assembled or disassembled beneath an energized power line. Planning this phase requires calculating a massive operational footprint. Site directors must account for the full length of the boom, the attachment of jib sections, and the working radii of any assist cranes required to piece the machine together. During dismantling, suspension ropes or pendants can catch on boom connection pins. When those pins are struck or removed, components can shift suddenly. These unpredictable, violent movements make it mathematically impossible to guarantee safe clearance beneath a live wire. There is only one legal workaround to this prohibition. The utility owner must completely de-energize the power line and visibly ground it at the worksite. Until the utility provides direct, affirmative confirmation that the line is dead, the assembly director must assume all overhead wires are energized and lethal. If the calculated assembly footprint overlaps the wire's drop zone, work strictly halts. You either kill the power or you relocate the crane. Before any lift commences near overhead wires, the site controller must formally identify the equipment's maximum work zone. If the line's voltage is unknown, meaning we assume it carries under 350 kilovolts, the absolute minimum clearance distance is 20 feet. This boundary must be physical or programmed. Crews must erect elevated warning lines equipped with flags, or program the crane's automated range limit devices to prevent the boom from physically breaching that radius. If the utility owner confirms the specific line voltage within the mandated 2-day window, operators can replace the blanket 20-foot rule with a precise alternative metric. This is OSHA Table A, which outlines minimum clearance distances based on the specific alternating current voltage of the line. The clearance distance scales exponentially. A 50 kilovolt line requires a 10-foot buffer, while a 1,000 kilovolt transmission line demands a massive 45-foot exclusion zone. Establishing these hard mathematical borders forms the foundation for preventing encroachment before a load is ever rigged. Moving a crane across a site without a load attached introduces an entirely different set of physical variables. For unladen travel, OSHA utilizes Table T, which dictates distinct clearance distances specifically for machines in motion. Uneven terrain causes the machine to bounce and sway. A small dip at the tracks translates into a wide, unpredictable arc at the tip of the boom. The speed of the equipment magnifies this pendulum effect, shrinking the gap between the steel and the wire. If the crane's travel path could bring any part of the machine within 20 feet of the line, the use of a dedicated spotter becomes legally required. The dedicated spotter has one strict function. They must have zero other duties on the site, except watching the clearance separation. They must be equipped with clear visual aids, like painted ground lines, and maintain continuous, direct communication with the operator inside the cab. Momentum and terrain dynamically alter a crane's geometry. When the machine is in motion, dedicated human oversight is the only defense for that invisible perimeter. There are rare circumstances where a required lift simply cannot be completed from a safe radius. For these situations, OSHA permits a limited exception. This exception is not a loophole for highly skilled operators to bypass the rules. Proximity to high voltage is governed by physics, not human dexterity. The process begins with a registered professional engineer, or the utility owner, calculating a new absolute minimum clearance distance specific to that exact lift. The engineer must calculate environmental variables that affect electrical arcing. They evaluate atmospheric conductivity, line sway, wind conditions, and the exact time it takes the machine to brake to a complete stop. Next, a mandatory planning meeting must convene involving the utility owner, the contractors, and site management to establish exact execution procedures. A critical outcome of this meeting is hardware control. The utility must physically disable the power line's automatic reclosing feature before work begins. Breaching the minimum clearance shifts the burden of safety entirely. It replaces standardized OSHA tables with custom-engineered physics and high-level bureaucratic coordination. The third phase of the exception requires the mandatory deployment of strict physical procedures and equipment modifications. An insulating link must be installed between the load line and the load, paired with non-conductive rigging to interrupt the current. On the ground, a physical barricade must be erected exactly 10 feet from the crane to prevent any worker from touching the machine. Any essential personnel permitted near the lift must be physically insulated from the earth. They must wear voltage-rated gloves or stand on insulating mats. If the operator is controlling the equipment remotely from the ground, they must use wireless controls that physically isolate them from the machine. Finally, all involved parties must appoint a single project director to oversee the implementation of these strict protective procedures. This director holds absolute authority to stop work instantly if a single clearance distance or procedural parameter is violated. If these strict engineered controls, specialized gear requirements, and command structures cannot be perfectly met, the lift does not happen.
Welcome to the site. We're excited about the progress. Don't forget to like this video and click that subscribe button to follow our journey.